Not since the East Coast-West Coast beef of the 90s has there been a rivalry so brutal and fierce like the one that's brewing right now across tech forums online. And it's no wonder there's problems, because this turf that they're fighting over is valued at over $100 billion. I'm referring, of course, to the vertical AI market and the battle over which is the best method to optimize a large language model for a domain-specific use case. And we need to put an end to this before it spills into the streets. There's already been multiple recorded incidents of extreme impoliteness at hackathons and pitch events. It needs to stop. Today, we're not only going to dive deep into the pros and cons of each method, we're also going to build a practical application on AWS. So what is vertical AI, and how is it such a massive opportunity? To understand vertical AI, we first have to understand its predecessor, vertical SaaS. SaaS is software as a service. It means that you're subscribing to an application online instead of downloading it and usually paying recurrent. Most of the SaaS products you'd know about are horizontal. Horizontal SaaS products serve diverse industries with general purpose tools, while vertical SaaS offers specialized solutions for specific industries or niches. It's not flashy, but it's super valuable. With vertical SaaS, the more boring the pitch is to the average person, the more valuable it is to that specific market. As it came to the world of SaaS, now it comes to the world of AI. And because you're diving deeper, you're creating more of a moat, more of an IP, because not any dude with a canoe can reach these depths. But that means it's not easy and you need to move fast. So what do you need to build a vertical AI product? Two things: domain expertise and data. Domain expertise means you have a deep understanding of the task or problem, and you know exactly how a high performer in that domain solves their problem well, so you can replicate those steps. And this impacts everything from the business logic to the user experience of your application. Second thing is the data, as much as possible. This is the detailed information about the domain, problem, or tasks that's not available publicly, and therefore it hasn't been used to train the general LLMs, which will be used to enhance the capability of an LLM for this particular vertical. Now, I'm going to assume that either you're a domain expert or you've acquired access to a domain expert by any means necessary, so that we can focus on the data. Now, you may have heard that data is your differentiator. It's true. So don't torpedo your future self by rushing to that $100 billion. Oh, it's 99 billion and a half now. So yeah, we're going to need to pick this up. Now, there are three main options for optimizing an LLM for a vertical AI use case: prompt engineering, retrieval augmented generation, also known as RAG, and fine-tuning. This is an LLM. We send it a prompt, we get back a response. Prompt engineering means enhancing what we send in the prompt to increase the quality and relevance of the response. It's the difference between having an LLM write a LinkedIn post for you that makes you sound like a charismatic thought leader instead of a cringy weirdo. But for our vertical AI case, we can use the elements of prompt engineering, especially few-shot prompting and system prompts, to make the LLM more relevant for our use case. Now, that prompt might look something like this. So in addition to the main question and task, we add this extra information and experience that it can have extra guidelines about what we're expecting. These are the services involved with communicating with an LLM on AWS. Amazon Bedrock is the main hub of generative AI. It's where you request access to models, create knowledge bases and agents and all that good stuff. Lambda is the serverless middleman that handles the communication with generative AI on Bedrock. API Gateway is what makes Lambda publicly accessible. In our case, a client front end that sends and receives messages. So here's how we're going to use prompt engineering for our vertical use case. Once we have access to a particular model, then we just copy the ID of the model. Then we create a Lambda function, and in a few simple lines using the Converse API, we have our basic communication structure for receiving a prompt, sending it to the LLM, and then returning the response. Now, instead of passing the message sent from our client directly, we can instead add our system prompt and a few short examples right here. However, this method can get out of hand and unreadable very quickly, especially if we have several versions of prompts and examples that we might want to change based on certain conditions. The much better way is to use prompt management on Bedrock, which is currently in preview. This allows you to write, save, and test prompts before using them. And then when you're satisfied with the result, you can just use a couple more lines to dynamically load any prompt with that prompt ID and pass it any variables. And that's how simple it is to add a lot of info and context with prompt engineering. Secondly, retrieval augmented generation, also known as RAG. This involves creating a knowledge base where we add our documents that contain the information that's required. This information is then indexed and embedded in a database or vector store. So now every time we send a prompt, the LLM will consult with our knowledge base, pull in the relevant information, and then use that as extra info and context for the result. Now, before creating the knowledge base, first we have to create the S3 bucket and add our files there, which are going to serve as the data that include the information and context that we want to use. And don't forget to sync whenever you add new files into the S3 bucket. And here's how simple it is to query our new knowledge base using another Lambda function just by passing the ID of that knowledge base. And now we get to fine-tuning. In contrast, fine-tuning uses custom data to train an LLM and alter the weights and produce a new model that is better suited to understand things using that data. This is the only one of the three approaches where we can say the LLM learned something new. Once you start fine-tuning, just click on the custom model section here within Bedrock, and then select Customize Model and Fine Tuning. Now, it's important to note here that different LLMs expect their training data in different formats. And as you know, one of the golden rules of data science is the longer you spend making sure your data is high quality and clean and relevant, the less suffering you're going to have later on. And though it's necessary, it does seem like it's going to be a bit of a harrowing detour away from us actually building our MVP. But luckily, we have some help. This sounds like a job for Amazon Q Developer. Amazon Q Developer is a code companion that sits in your IDE and helps a lot with developing software and generating assets on AWS. So in our case, I want to tell Amazon Q that I'm preparing a data file to be used to fine-tune a specific model on Bedrock, and that I want it to help me write a Python script that transforms the way my current data is into the correct format to train a Titan Text G1 Lite model on Bedrock. And here it is. It's generated the Python script, and it's also told me the exact steps I need to run it. And it's explained the formatting also that's expected, so I know so that I understand that. And that's a lot of time saved that I can now put into building my prototype or testing the different optimization functions to see which one is the best for my use case. So now we finally get to the $99.5 billion question. 99.3. Which one is the best approach? As with most things in life, the answer is a clear and resounding, it depends. So let's start with some broad guidelines and an oversimplified flowchart that's definitely going to annoy some people. If you have limited examples and data and you're just looking for quick adaptations and context, prompt engineering is good. If you have complex tasks or large amount of data, prompt engineering is bad. If you have tasks that require large, frequently updated knowledge and information, RAG is good. If you're looking for deep reasoning tasks with limited computational resources, RAG is bad. If you have specialized tasks with substantial task-specific data, fine-tuning is good. If you have limited data, frequent knowledge updates, or limited computational resources, fine-tuning is bad. Now let's pull everything together in a practical example. Trigger alert, I won't be using one of the methods. I will be using all of them. Now again, every use case is different, but here's how it might look like for a deployed vertical AI product that provides financial regulations advice for fintech startups. First, the initial prompt can go through one of several caching mechanisms to enhance the performance based on previous conversations. Then it can be embedded within a system prompt that provides guidelines on the expected role, the output format, and use few-shot prompting with some common examples in fintech. Then it will retrieve the most recent regulations and compliance laws from a knowledge base. And this aggregated prompt information will then be passed into our fine-tuned LLM, which has been trained on thousands of real financial cases and is able to spot trends and adapt to new situations and provide insights. And finally, the output of the LLM can go through guardrails which prevent harmful content, topics that are important to avoid legally, and drastically reduce hallucinations, so we can make sure that our clients are getting exactly the quality information that they expect from our product. And all of this is orchestrated from within Amazon Bedrock. The great thing about deploying GenAI applications with Bedrock is that you don't need to worry about the scaling and performance issues. Bedrock handles all of that, and you can focus on continuously providing more value to your customers. I really hope you enjoyed this video, and I'd love to hear from you below about what you're building, if you want me to dive deeper into anything I discussed today, or if you have any questions. My name is Bassel Fatin. I'm the Principal Tech Evangelist at AWS, and I'm here to help you bring your ideas to life using generative AI on AWS. Thanks for watching.